So the number of strictly increasing functions, the question here is number of strictly increasing functions from set 1 1 to 6, set 2 1 to 9, such that f of I is not equal to I is between 1 and 6. So please remember, increasing function means x greater than y implies f of x greater than f of y, and also here it is given f of I is not equal to I implies f of 1 is not equal to 1. So the least possible value of f of 1 is 2. So let us take the first case, f of 1 is equal to 2. Once we take f of 1 as 2, then out of these remaining 1 2 3 4 5 6 7, out of these 7 elements we have to choose 5 elements, so that is 7c5. And once you choose it, they can be mapped in only one way because it's given increasing function. So the least of this chosen 5 will be the image for 2. The second least will be image for 3, and so on. So once you choose it, they can be mapped in only one way, please remember. Now let us move on to the second case. F of 1 is equal to 3. So if f of 1 is 3, so 1 is mapped to 3. So now here 1 2 3 4 5 6, out of these 6 elements we need to choose 5 elements. So once you choose it, again it can be mapped in only one way, so 6c5. Now the next case is f of 1 is equal to 4. Suppose if I take f of 1 as 4, then remaining there are 5 elements here, and here there are 5 elements. So which means out of these 5 elements I need to choose 5 elements, and they can be mapped in only one way, so that is 5c5. And please remember, f of 1 is equal to 5 is not possible, because if 1 is mapped to 5, then there are only 4 elements here and there are 5 elements here, so we cannot map. Hence the answer is 21 plus 6 plus 1, which is equal to 28. So answer is 28. Okay, here the question is the largest n belongs to n such that 7 power n divides this. So basically we need to find out the highest power of 7 in 101 factorial. So please remember, whenever you want to find highest power of a prime number in n factorial, just keep dividing it. Like 101, you take it and divide by 7. 7 ones are 4s are 7 2s are. So the highest power of 7 is nothing but 14 plus 2. Therefore 7 power 16 divides 101 factorial. Therefore according to this problem, n is equal to 16. So what is given here is, there is a triangle. Let us call this as A, B and C. So it is given that 4 points are taken on AB. So let us take 4 points, 1 2 3 4, P1 P2 P3 P4, and 5 points on BC, 1 2 3 4 5, P5 P6 P7 P8 P9, and 4 points on AC, 1 2 3 4, P10 P11 P12 P13. Now the total number of pentagons. The number of pentagons means, please try to understand, we need to select 2 from one side, 2 from another side, and 1 from the third side. And 2 2 1 gives the pentagon, but please remember 3 1 1 does not give you the pentagon, because if you choose 3 points from one side, 1 from other side and 1 from other side will not give you the pentagon. Okay, what we have to do here is, let us consider AB, BC and CA. So AB has 4 points, BC has 5 points and AC has 4 points. Now we can get a pentagon if I choose 2 from this, 2 from this, 1 from this. Suppose if I choose 2 from this, 2 from this and 1 from this, I'll be getting a pentagon. So this is what the pentagon is. So this can be done in, out of 4 I need to select 2, and out of 5 I need to select 2, out of 4 I need to select 1. Similarly 2 from this, 1 from this, 2 from this, and 1 from this, 2 from this, 2 from this. So this gives 4c2 into 5c1 into 4c2. Similarly 4c1 into 5c2 into 4c2. This gives 6 into 10 into 4, and 6 into 5 into 6 and 4 into 10 into 6. So this is 240, 180 and 240, which gives 660. So 660 pentagons are possible. Okay, here total number of numbers given is 11, and the number of elements in A we need to find out, where A contains all subsets of S such that each set has greater than or equal to 2 elements and the product of all the elements must be even. So basically what it means is all odd numbers should not be there. That's what it means. So let us first take 1, 2, 3 and so on up to 11. So the total number of subsets is 2 to the power of 11. Now let us take odd numbers 1, 3, 5, 7, 9, 11. So total number of subsets is 2 to the power of 6. Now if you subtract this, so 2 to the power of 11 minus 2 to the power of 6, 2 per 11 minus 2 per 6 is the total number of subsets minus the sets which contains only odd numbers, which is what we do not want. But at the same time it is given that n of b is greater than or equal to 2. So which means the singleton sets are not allowed, but we have not subtracted the singleton sets which contains even numbers. So basically 2, 4, 6, 8 and 10. So these are all the 5 subsets which are included in this. So this also must be subtracted. That gives the final answer. Therefore answer is 2 per 11 minus 2 per 6 minus 5. Therefore answer is 1979. Here the question is the number of 4-letter words with or without meaning which can be formed using the letters of the word P, Q, R, P, Q, R, S, T, U, V, P. Now very first thing what you have to do here is we are talking about the 4-letter words. So let us categorize this into different symbols that are available. So P is coming thrice. So P, 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 and then Q twice, and then R twice, and then all remaining only once. So S, T, U, V. Okay. Now let us take different cases based on the nature of the 4 letters. So what do you mean by nature of the 4 letters? So the all possible cases. So which means very first possible cases all are of same type. So which means all 4 are of same type means which is not possible. 1, 2, 3, 4, which means there is no letter here which comes 4 times. So hence answer is 0. So in this case, let us move on to the second case. 3 same and 1 distinct. What do you mean by this? 3 same, 1 distinct means 3 letters are same means here it has to be PPP only. So let me just fix it here, PPP. Now what we have to do here is we have to choose one letter out of Q, R, S, T, U, V. So which means 1, 2, 3, 4, 5, 6. There are 6 symbols that are available. Out of these 6 symbols, we need to select one. So which means this can be done in 6C1 into number of ways we can arrange this is 4 factorial by P comes thrice. So 3 factorial. Let's move on to the third case. 2 same, 2 distinct. So 1, 2, 3, 4. So which means here 2 same, let me assume that it is P, P. Now 2 distinct, again from Q, R, S, T, U, V, 2 distinct has to be chosen, which can be done in 6C 2 ways, but these 4 can be arranged in 4 factorial by 2 factorial because P's are identical. So here very important thing here is we have taken it as PP. Instead of PP, it can also be QQ or RR. So total we have to multiply by 3. The reason is this 3 is because PP or QQ or RR. Fine. Let's move on to the fourth case. That is 2 same of one kind and 2 same of another kind. So what do you mean by this? 1, 2, 3, 4. Here S, T, U, V is not possible. So which means among P, Q, R, out of these 3 symbols, we need to select 2 symbols. And this can be arranged in 4 factorial by 2 factorial into 2 factorial. Now the last case, which is all distinct. So all distinct means here 1, 2, 3, 4. Out of 1, 2, 3, 4, 5, 6, 7. Out of 7 symbols, we need to select 4 symbols, and this has to be arranged in 4 factorial ways. So finally, if you see here, so you'll be getting answer. So first case it is 0. Second case it is 6 into 4, 24. And third case is, if you evaluate this, you'll be getting 540. And next fourth case it is 18, and the last case it is 840. So totally you will be getting 1422. So answer is equal to 1422. Here the question is number of ways in which 16 oranges can be distributed to 4 children such that each child gets at least 1 orange. So basically what it means is, let x1 be the number of oranges given to the first child, let x2 be the number of oranges given to the second child, let x3 be the number of oranges given to the third child, and x4 be the number of oranges given to the fourth child, and sum of all the oranges must be 16. Now very important thing here is x1, x2, x3, x4 are integers and should be greater than 0. So basically it means positive integer solutions. Positive integer solutions. Okay. Now very important result. Let me just recall here. Very important result. Suppose if I have x1 plus x2 and so on up to xr is equal to n number of positive integer solutions is equal to n minus 1 c r minus 1. So here please remember, here n is equal to 16 and r is equal to 4. So therefore answer is nothing but 16 minus 1 c 4 minus 1, which is equal to 15 c 3. This is nothing but 15 into 14 into 13 by 1 into 2 into 3, which is equal to 455. So answer is 455. Okay. Here S denotes set of 4-digit numbers ABCD such that A is greater than B is greater than C is greater than D, and P denotes set of 5-digit numbers such that the product of its digits is equal to 20. So let us take the first case, yes. So what is yes? A 4-digit number ABCD such that A is greater than B is greater than C is greater than D. Okay, here we have totally 10 digits. Out of 10 digits, we need to choose 4 digits, which can be done in 10C4 ways. That's it. So this is equal to 10 into 9 into 8 into 7 by 1 into 2 into 3 into 4, which is nothing but 210. So number of elements in yes, is equal to 210. Fine. Let us move on to P. So what is P here? 5-digit number. So let me take a P, Q, R, S, T as the 5-digit number, where here product is equal to 20. So which means P, Q, R, S, T is equal to 20. Okay, 20 we have to write it as product of 5 numbers. So which can be done in 1 into 1 into 2 into 2 into 5. This is one possibility which can be arranged in 5 factorial by 2 factorial, which is nothing but 30. And second possibility is 1, 1, 2 into 2 is 4. So 1, 4, 5. So P is 1, Q is 1, R is 1, S is 4, T is 5. So this also is one possibility. Hence, this can be arranged in 5 factorial. Arrangement is very much required because P, Q, R, S, T are different numbers. 5 factorial by 3 factorial, which is nothing but 20. So final answer is 50. Therefore n of p is equal to 50. So answer is n of s plus n of p is equal to 210 plus 50 is equal to 260. Okay. The number of numbers greater than 5000 less than 9000 which are divisible by 3 such that can be formed using these digits 0 1. So the digits here are 0 1 2 5 and 9 if the repetition of digits is allowed. Here the question is the number of numbers between 5000 and 9000 means it's a 4-digit number. So that is very clear. So let us consider this 4-digit number. Greater than 5000 less than 9000 means it's very obvious that the first digit must be 5. So what we are going to do now here is, let us assume that the sum of this is equal to x, and we know that the number is divisible by 3 if sum of all the digits is divisible by 3. So what we are going to do now here is, we are going to take cases based on x. So the least possible value of x is 1, so that 5 plus 1 is 6. So which means 6 means the 4-digit number is divisible by 3. So this gives 0 0 1. So this can be arranged in 3 factorial by 2 factorial, which is equal to 3 possibilities. Next is, we need to keep adding 3, because if you take any other number, the sum of the digits will not be divisible by 3. So let us take x as 4. So x as 4 means we have 0 2 2, one possibility, and similarly we have 1 1 2. So this case is 3 factorial by 2 factorial, which is 3, and this case is 3 factorial by 2 factorial, which is also 3. Let us move on to the next case, x is equal to 7. So x is equal to 7 means again 0 2 5, one possibility, and the other possibility is 1 1 5. So here the first case 3 factorial, there is no repetition, which is equal to 6, and here 3 factorial by 2 factorial, which is equal to 3. Now comes next x is equal to 10. X is equal to 10 means 0 1 9, this is one possibility. Similarly 0 5 5 is the another possibility. So here the first case all digits are different, so 3 factorial is equal to 6, and here 3 factorial by 5 comes twice, so 2 factorial, which is equal to 3. Next comes is x is equal to 13. X is equal to 13, we have 9 2 2. 9 2 2, this is the only possibility. So 3 factorial by 2 factorial, which is equal to 3. Then x is equal to 16. X is equal to 16 has one possibility, 9 5 2. This gives 3 factorial because all digits are distinct, so it is 6. And x is equal to 19. I think 22 is not possible, so 19 is the last possibility. So we have 9 9 1. So this can be done in 3 factorial by 2 factorial, which is equal to 3. And the other possibilities, we can have 9 5 5. So which can be done in 3 factorial by 2 factorial, which is equal to 3. So answer is nothing but, you need to just add all these 1 2 3 4 5 6 7 8 9 10 11 12 13 14. 14 threes are 42 is the answer. Here the largest value of n for which 40 per n divides a 60 factorial. So very important thing here is, please remember 40 is not a prime number, so we have to convert it into a prime number. So 40 is nothing but 2 cube into 5. So we need to find out the highest power of 2 cube and highest power of 5. So let us first find out highest power of 2 cube. So to find out highest power of 2 cube, first we should find out the highest power of 2. So 60 divided by 2, 30, 2, 15, 2, 7, 2, 3, 2, 1. So sum of all these sum of all these, you just add all these, that will be the highest power of 2. So highest power of 2 is nothing but 45, 55, 56. Therefore, this is nothing but 2 power 54 into 2 square, which is nothing but 2 cube power 18 into 2 square. So this is nothing but 8 power 18 into 2 square. So therefore, the highest power of 8 is highest power of 8 in 60 factorial is 18. Similarly, so what you have to do now here is highest power of 5 we need to find out. So highest power of 5, 60 divided by 5, which is 12, divided by 5, which is 2. So finally we'll be getting 12 plus 2, which means highest power of 5 is 14. So highest power of 5 is nothing but 14. Now highest power of 5 in 60 factorial is equal to 14. So therefore the answer is least of 14 and least of 14 comma 18, which is nothing but 14. So answer is equal to 14. Okay, this is one of the very important and repeated question. The letter of the word Udaipur are written in all possible ways with or without meaning, and these words are arranged as in the dictionary. Dictionary order means, I think all of you know, if the first letter is same, then second letter will be in alphabetical order. If first two letters are same, third will be in alphabetical order, and so on. So what is the rank of the word? Rank means position. So before getting into the problem, very first important thing is first arrange these letters in the alphabetical order. It will be easier. So first comes is A, after A is D, after D is P, and after P is R, U, U is twice, and Y. So this is the alphabetical order of all the letters which are there in Udaipur. Now what we have to do here is, very first thing is the one which starts with A. So 1, 2, 3, 4, 5, 6. So these 6 places can be arranged in 6 factorial by u comes twice here. So 2 factorial, which is nothing but 360. So there are 367 letter words starting with A. Similarly, starting with D, 1, 2, 3, 4, 5, 6. So same answer, 6 factorial by 2 factorial, which is 360. Next, starting with P, 1, 2, 3, 4, 5, 6. So same answer again, 6 factorial by 2 factorial, which is 360. After P, again R. So starting with R, 1, 2, 3, 4, 5, 6. 6 factorial. 6 factorial by 2 factorial, which is nothing but 360. After R comes U. It's a very important one. After R comes U. But please remember, we are looking for the word Udaipur. So where the first letter is U, and here also we got U. So what we have to do is we have to fix one more letter here. So here one more letter has to be fixed because the first letter is coinciding. So again we have to come in the alphabetical order, please remember. So UA, let me fix it here, 1, 2, 3, 4, 5. So answer is 5 factorial, which is nothing but 120. So after UA, so U after A, it's UD. So please remember UD here and here also UD. So two letters are same. So we have to fix one more in alphabetical order, which means UDA. And it's very clear that the first three letters are same. So we have to fix the fourth letter, which is P. Okay. So 1, 2, 3. This can be filled in 3 factorial ways, which is nothing but 6. So after this UDA, after P, it comes R. So again 1, 2, 3, which is again 3 factorial, which is equal to 6. And then U D A, after R comes U. So again 1, 2, 3. So it becomes again 3 factorial, which is equal to 6. And then U D A, after U comes Y. And a very interesting thing here is the first four letters are same, U D A Y and U D A Y. So you have to fix the next letter. A is already there, and D is already there, P. So P here. So again first 5 letters are same. So we have to fix one more. A is already there, D is already there, P is already there, R comes here. So this can be filled in only one way, that is 1 factorial 1. And next comes is U, D, A, Y, P. After R it comes U, and finally the remaining R. So this gives 1. So final answer is sum of all these, which gives 1580. So therefore rank of the word is equal to 1580. Here let S is given as collection of all polynomials where ABC are natural numbers and ABC less than or equal to 20. Set of all polynomials is given here. Then the number of polynomials such that it is divisible by x square plus 2. So which means x square plus 2 must be a factor of this polynomial. So what we are going to do here is let x cube plus ax square plus bx plus c is equal to x square plus 2 into, because this is a cubic polynomial and this is already quadratic, there must be a linear polynomial. Under the linear polynomial I can take it as x plus p. So why I am taking a quotient of x as 1 is because x square into x is x cube, and here also it is 1x cube. So here if I take quotient of x as 1, then only I will be getting 1x cube. So here what this gives is x square plus px square plus 2x plus 2p. So comparing these two, finally we will be getting b as 2 and a as p and c as 2p. So from these two I can say that a, if I substitute here, so c becomes 2a. So what we are getting is b becomes 2 and c is equal to 2a. So this is the condition. So basically we need to choose a. Once you choose a, all possible cases will be getting. So the values of a are 1, 2, 3 and so on up to 10. A cannot be 11 because if a is 11, c becomes 22, which doesn't come under the given range. So therefore 10 is the answer. Here s is given as 1, 2 and so on up to 8. X is the number of 9-digit numbers formed using the digits such that only one digit is repeated and it is repeated twice. And similarly y is the number of 9-digit numbers such that only 2 digits are repeated and each is repeated exactly twice. So let us take the first case, x. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So here let's assume that the repeated thing is a and a. So a is repeated. So which means one of the digit is repeating here. So out of these 9 I have to choose that one which is repeating. Which means out of these 9 I have to choose a. So this can be done in 9C1 into the remaining 7. These are the 7 places, 1, 2, 3, 4, 5, 6, 7. These 7 digits I have to choose it from the remaining 8. So this can be done in 8C7 into, finally we have to arrange this. So that can be done in 9 factorial by 2 factorial. This is what x is. Okay, now similarly let us take this y. So what is y? 1, 2, 3, 4, 5, 6, 7, 8, 9. So here it is given that 2 digits are repeating. Let's call it as A, B, B. So which means 2 digits A and B, I have to choose it from the 9. So that can be done in 9C2. Now these 5 digits 1, 2, 3, 4, 5 has to be chosen from the remaining 7 digits. So which can be done in 7C5 into these 9 digits can be arranged in 9 factorial by 2 factorial into 2 factorial. So this is what y is. Now let us try to find out x by y. Instead of evaluating this and wasting the time, let's find out what is x by y. So 9C1 into 8C7 into 9 factorial by 2 factorial by 9C2 into 7C5 into 9 factorial by 2 factorial into 2 factorial. So this is nothing but 9 into 8c7 is same as 8c1. So 8 into 9 factorial by 2 factorial by 9c2 is 9 into 8 by 1 into 2. 7 5 c5 is 7c2. 7 into 6 by 1 into 2. And this is 9 factorial by 2 factorial into 2 factorial. So here we can see that this 9 into 8, 9 into 8 cancel, 9 factorial cancel, 2 factorial and 2 factorial also cancel, and this also will get cancel. So finally I'll be getting 2 by 21. So finally I'll be getting 2 into 2, 4 by 21. So 4 by 21. Therefore answer is 21x is equal to 4y. So first option. Here it's given that 3 persons enter into a lift at the ground floor. So let us assume that this is the ground floor. So totally there are 10 floors, and the lift goes up to 10 floors. So which means floor 1, floor 2, floor 3, floor 4, floor 5, floor 6, floor 7, floor 8, floor 9 and floor 10. These are the 10 floors. Let's assume that. The number of ways in which the 3 persons can exit the lift at 3 different floors if the lift does not stop at the first, second and third floors. So what is given here is the lift does not stop here, does not stop here, does not stop here. So which means out of these 7 floors, these 3 people can exit in how many ways? That is a question. So what we have to do here is, out of the 7 floors, you choose 3 floors and you can arrange these 3 people in 3 factorial ways. So finally you will be getting 35 into 6, which is nothing but 210.